Hi, I'm Greg Murray for the Holland Climate Collaborative, and we're here today to talk about climate change and heat stress in humans and animals with my longtime colleague and dear friend, Dr. Chris Barney. Dr. Barney is originally from that state to our southeast that shall not be named, and he got his Bachelor's of Science degree in biology at Wright State University there, and then his PhD in physiology at Indiana University. After that, he did a postdoctoral fellowship at the University of Florida and then finally joined the Hope faculty in 1980 in the Department of Biology. Dr. Barney is a medical physiologist whose research career centers largely on the interactions of the systems mammals use to regulate their body temperature and water balance. He retired officially in 2017 as the T. Elliott Weir Professor of Biology, but he's still doing collaborative research with other faculty and students. So we don't really let him talk about retirement most of the time. So welcome, Chris.
Thank you, Greg. Thank you very much for inviting me to participate. I appreciate it. I think this is a very interesting and important project you have going on, and I wish you a lot of success with it.
Well, thanks. We appreciate you being here. So as a physiologist who studies temperature regulation, you're just the perfect person to ask about some of the effects of climate change on people and animals. You probably know that in the last 40 years or so, the average global temperature has increased by about 1.5 degrees to 2 degrees Fahrenheit, and that climate scientists project an up to 10-degree increase by the end of this century. So why are increases like those a concern for the health of humans and livestock and pets?
That's a good question. And of course, if you think of 2 degrees, you think, well, that's really not very much. If you go from 58 degrees to 60 degrees, you wouldn't even notice. 75 to 77, probably wouldn't even notice. But sometimes 2 degrees can be really important. So at the other end of the extreme, if you go from 31 to 33, you've gone from snow to rain. In terms of the higher temperatures, if you go from, say, 94 to 96, that's going to have a lot more effect upon you than going from 75 to 77. Going from 94 to 96, for example, will increase sweat rate from 10 to 50%, depending on how active you are. So just a small change, once you're warm enough, can have significant physiological effects. And of course, if there's a 10-degree increase, that's going to be really magnified. But physiologists are really much more worried about heat waves or extreme heat events. Those times when temperature goes up for a prolonged period of time to quite high levels. And for example, in 2003, there was a heat wave in Europe. And it was calculated there were 15,000 extra deaths in Europe during that heat wave that they could attribute to direct or indirect effects of the heat. So climate scientists predict that in the next 50 years, that heat waves are going to become much more common. They're going to become more widespread. They're going to be more intense. They're going to last longer. And as I said, they're going to be more common, from 10 to 50 times more heat waves. So you can just imagine that as those events become greater, there's going to be a really big impact on human and animal health because of the heat.
So beyond being just uncomfortable, what are the physiological effects that are more serious?
Well, let's just talk about some normal physiological responses first. So when people are exposed to the heat or temperature goes up, they first use behavior to try to keep cool, to regulate their body temperature. So you aren't wearing what you and I are wearing today, flannel shirts. You wear t-shirts or shorts. So you change your clothing to try to cool down. And you tend to become less active. You don't go out and run around like crazy. As they say, only mad dogs and Englishmen go out in the midday sun. And another thing you do is you drink more cold beverages. That will help cool you down too. And then if you can, you go inside and you turn the air conditioning on. So whenever we can, humans and, excuse me, other animals too will use behavior as a means of escaping the effects of the heat. But if that doesn't work or is not possible, then humans will have an increase in the amount of blood their heart pumps. So your heart starts beating faster and a little more strongly, and that allows you to push more blood out to your skin. Your skin warms up, it can either radiate away heat, or if it's warmer, it will absorb less heat. If that's not enough, then you start to sweat. And sweating is a very effective mechanism for cooling. It's one of those traits in humans that allowed us to move so far around the globe. There's a trait that occurred very early in human development, so it was sort of there from the beginning. The issues with sweating, though, is primarily that, of course, you have to use water to sweat. And as that water is used up, you become dehydrated. And dehydration is not too good. If you're dehydrated, then you want to replace that water because you get thirsty. So you think, well, I'll just drink some water, be okay. Unfortunately, when you sweat, you also lose salt in the sweat. Salt is one of the major drivers for thirst. So since the salt is lost, you're not as thirsty as you should be. So that means, say, if you lose 2 liters of water in sweat, you really are only going to replace about half of that before you're not thirsty anymore. Once you drink 1 liter of water, you don't feel thirsty anymore. And that means you stay dehydrated. For a while there, scientists were saying, well, then just force yourself to drink water. And they were particularly for athletes who were out in the heat. And then they realized that that wasn't good either, because if you drink too much water, your salt levels go way low. It's called hyponatremia. And that can cause immediate devastating nervous system effects. So it's like we're caught between a rock and a hard place. Either stay dehydrated or you get hyponatremia. The problem with dehydration is that it has all kinds of negative effects too. First, you can't work as well. You just don't have the energy to, well, you have the energy, but you don't have the blood flow to allow you to work very much. You get reductions in kidney output. So your kidneys don't work as well. And in fact, that's one of the main ways of telling if you're dehydrated by how much urine you produce. And interesting, you have mental cognitive issues. So dehydrated people don't think as clearly, they don't react as well, their memories are not as good. So things that are sort of subtle but can have a big effect. When I was in graduate school, I took part in this heat stress experiment. They put me in a hot room and had me walk on a treadmill and wouldn't give me any water. So at first I'm sort of uncomfortable from the heat and all the pros, but as I kept walking, I got thirstier and thirstier and thirstier. By the end, I would have almost traded my wife for a glass of water. Now that's an example of cognitive problems. You know, I'm not in my right mind, I wouldn't give away my wife for anything, but I almost would have done it. So dehydration can have some really significant effects, and including a higher risk for heat stroke. When we think of extreme heat events and human health, that's what usually comes to mind, heat stroke.
So I have to admit, I don't really understand exactly what heat stroke is. I mean, you hear the term a lot, but I'm sure that you're mentioning it because it is a particular thing that involves certain symptoms. So can you enlighten us about what heat stroke is and how serious it is?
So heat stroke is very serious. It's because it can happen quickly, and it can be a cause of death. In the United States, about 450 people a year die of heat stroke. Now, of course, if you predict a 10 times increase in heat waves, you can expect a 10 times increase in heat stroke as well. Heat stroke occurs when your inner body temperature, core body temperature, reaches about 104, 105 degrees. And at that temperature, your system just sort of falls apart. It used to be thought that the main cause of problems or of death was that the part of your brain that regulates your body temperature just sort of overheated, and then everything just fell apart. And there's still some effects there. There's still some direct effects on the brain. For example, if you have heat stroke, you become a very confused, agitated. If it gets to a certain point, you start to have seizures. This goes along with increases in heart rate and all kinds of other physiological responses. But more recent studies have shown that the increased body temperature leads to an increase in the leakiness of your digestive tract, particularly your intestines. And when the intestines become leaky, the bacteria that are just normal part of your inside of your intestines leak into your blood. Well, this is not where they're supposed to be. And those bacteria will cause essentially septicemia, blood poisoning. Your immune system has this massive inflammatory response. And it's been shown that this inflammatory response is what's really responsible for the organ damage that leads to so many problems. Another factor is that heat stroke leads to what's called disseminated intravascular coagulation. And basically that means that your blood clots inside your blood vessels. And if your blood clots inside your blood vessels, it's bad news for your organs. It just stops the blood flow to your organs. As a diver, the bends or something like that too. You get air bubbles that stop blood flow. Well, here the blood just coagulates. So you get massive organ damage, and that leads to death. If you don't die, and it's been shown that about 30% of people who have heat stroke end up with permanent brain problem, permanent brain damage. So it's something you want to avoid if you can. So heat stroke, the biggest direct effect of heat exposure in people who aren't able to put up with it.
Okay, so yeah, thanks. I didn't know about a whole bunch of that. Is there a particular group of people that are more susceptible to the effects of heat stress and especially heat stroke?
There are. Before I talk about those people, I want to just mention a couple other effects of heat stress that can be deleterious to humans. Heat stroke being the rapid is the most severe, but they've shown that during heat waves, there's a significant increase in hospitalizations and deaths due to cardiovascular disease. So more heart attacks, strokes, things like that. They've shown that there's more hospitalizations and deaths due to people with chronic respiratory disease, asthma, chronic obstructive pulmonary disease. Heat leads to more problems there. It's also been shown that heat waves can lead to problems with reproduction. So if you, in one study, they looked at, I think, over 1 million pregnancies in California and showed that during heat waves, there was a increase in premature births, and premature and low birth weights. Premature births are one of the major factors in infant mortality. So you can see that there's this link there as well. And interestingly, in the last 20 years, I think, a new sort of syndrome has been described in the scientific and medical literature, and agricultural workers, particularly those in southern Mexico, Central America, other places like that, the Central Valley of California. There's been this epidemic of chronic kidney disease. So it turns out that these agricultural workers are exposed to the heat day after day. They become dehydrated, and that repeated heat stress and dehydration leads to kidney damage. And something like 30,000 deaths have been attributed to this in the last 20 years. Just a massive thing. One author described it as the first real pandemic that's due to a global warming. A really interesting thing about this is that there's an interaction between that heat stress and dehydration and sugary beverages. They saw that there was more kidney damage in the workers who drank sugary beverages like soda pop and things like that than in the ones who drank water. So one of the first things they're doing is trying to get these workers to drink water instead. So that's a pretty serious concern for global warming as well. Now back to your question about risk groups. As with so many other things, the elderly are a very at-risk group, more so than other individuals. This is because they have poor ability to regulate temperature. So they don't have as much blood flow to the skin, don't sweat as much, and they also tend to be chronically dehydrated. The studies have shown that as one gets older, like people with gray beards and gray mustaches and things like that, as people get older, their sense of thirst decreases. So these people are dehydrated, but they don't know they're dehydrated. And of course, that's even worse than when they're exposed to heat. Plus, they don't even seem to know they're being heat stressed. So
how much worse it must be? How much worse it must be for people your age?
Yeah, that's exactly it. People my age, any thirst responses at all.
Sorry,
I have to watch.
Couldn't resist.
I really do. I have to seriously cause myself to drink a little bit more water than I used to, because I know to myself I'm not as thirsty.
Huh.
So they're at the biggest risk problem. A second group are infants and small children. They're at risk. Well, they tend to be dehydrated a bit too, and of course they don't have a lot of awareness, and even if they're hot, they can't really tell you they're hot. But one issue is they have high metabolic rates for their size, and because their bodies are smaller, they can heat up a lot faster.
Mm-hmm.
And so, well, as we see, every year, the tragic deaths of children that are left in hot cars, whereas an adult could tolerate that more because of their what's called thermal inertia. They just take longer to heat up. Small children, infants, just don't have a chance. So you have to particularly watch for them. So I mentioned people with chronic diseases, COPD, diabetes, hypertension, they're at greater risk. And of course, if you work outside, you're at greater risk than the people that work inside an air-conditioned office or classroom. Agricultural workers, as we mentioned, construction workers, military, first responders, delivery people, anybody who has to be outside and have to stay outside. When I was in college, I worked in construction. I worked for a stonemason, and I couldn't just say, "Oh, I'm done for the day" when I got too hot. It was just you're outside working a lot.
Yeah.
And then probably the group that we could do something about the easiest, but we don't, are the people with limited financial capabilities. If you can't afford air conditioning, you can't turn up the air conditioning. You can't go inside where it's air conditioned. So there's a large number of people who just don't have the resources to do that. And I'm not saying people in Mesoamerica. There are people in Holland, Michigan, who don't have the resources for air conditioning. So they're at risk as well. So lots of different groups.
Mm-hmm. So beyond the really severe effects like heat stroke, as you were talking about, it's just a threat multiplier for a whole bunch of things, both sociological and biological.
That's right.
Interesting.
It's something most people think, well, a couple of degrees, that would be nice, but no, it's not going to be nice.
Yeah. Well, but it's, in a way, it's a little bit like, floods too. I mean, and sea level rise. I mean, a couple inches sea level rise is not a big deal until you also happen to have a flood and a storm on top of it. And then that couple of inches is magnified greatly because of the wind and the tide and stuff like that. Do non-human mammals like a lot of our pets and our livestock react in the same way to higher temperatures and have heat stress and heat stroke effects like we do?
They do. And in fact, our pets and livestock are at more risk of heat stress than humans are. There was a book, I think it came out in the 60s, called The Naked Ape. And
Desmond Morris.
Desmond Morris. It stressed in part that humans don't have a lot of insulation, but dogs have fur, and sheep have wool, and cows and horses have hair, and ducks and geese and canaries have feathers. These are all good insulators and help the animals survive in cold environments, but they don't help generally in warm environments. So they have more insulation, and then they don't have as good an ability to use evaporative cooling, like sweating that we do. For example, cats, dogs, birds, pigs, rabbits, none of those animals sweat, okay? So to keep cool, cats, dogs, birds pant. So they just start breathing more rapidly. And if you have a dog and you're out in the heat, you know that occurs a lot, panting and drooling and stuff. Well, that can keep them cool, but it's not nearly as effective as sweating for two reasons. One is sweating covers the whole body surface pretty much, but with panting, it's just in the mouth and the nasal area. And that allows you to cool the blood going there, but it's not like the whole body. The other thing is that you actually have to increase metabolic rate to pant when you don't have to do that sweat. So the animals have to breathe more often, and they have to use more energy to do that. So that doesn't work very well. Pigs are even worse. They don't sweat or pant. So pigs have to wallow, essentially. They try to find some wet area, cover themselves up, which the mud sort of directly affects them, protects them from the skin, from the heat of the sun, but also the water in the mud can evaporate and cool them down. So if you're a pig farmer, you're really concerned about the heat. Horses and cows can sweat, so can sheep and goats, but not nearly as effectively as humans do. Although horses seem to do a pretty good job at it. Interestingly, goats and sheep seem to do better in the heat than you would expect. So some breeds at least are sort of seem to have been adapted to heat. So they're a little bit more. But if you have livestock or pets, you have to be really careful of that. Besides heat stroke and the immediate death animals, that if you're a farmer, you worry about the fact that they're going to eat less and grow less in the heat. Reproductive rates and ability goes down. Milk production goes down. Egg production goes down. Egg quality goes down. If you're a hog farmer, meat quality can go down. So there are these effects of heat on your livestock that's going to have a significant economic impact. In 2017, the sale of poultry and eggs in Ottawa County was worth $114 million.
Wow.
You can see that a major heat event in Ottawa County could wipe out millions and millions of economic gains, which would, of course, not just affect the producers, but would go right on through the thing. So in addition to the welfare of the animals, which we of course care about, you have to think there's going to be an economic output as well, impact as well.
Well, we're coming toward the end of our time here, Chris, but this has been fascinating, and I've learned a lot. I wonder, do you have any sort of parting thoughts before we tie it up?
Again, I really appreciate being asked to talk a little bit. I love talking about biology, and I'm concerned about the effects of climate change, like most scientists are. So anything we can do to help raise awareness is good. I think you just have to keep in mind that this global warming is occurring, and it's going to have a significant impact on human health, livestock, and pets, and we have to think about it. I think about it the way sort of like I think about termites. So if you have some termites in your house, they're doing damage. They're eating the wood. And so you may call your neighbor over, and the neighbor says, "Oh, don't worry, those are just flying ants. You don't have to worry about it." But if you don't take care of your termites, they do more and more damage and more damage. And then eventually you discover this damage, and then you can either say, "Okay, well, I'm going to have to pay a lot of money now to get rid of the termites and to fix the house." Or you can say, "I'm not going to do anything." And then you're going to have to pay a lot more money when your house falls down on you.
Yeah.
That's if you don't die because you were in the house. So
Right.
global warming is this sort of insidious thing that we've brought upon ourselves, and it's up to us to do something about it. And hopefully your program will help do that.
Well, thanks. It's a lot to think about, and I sure appreciate you being here. And as you love to talk about biology, of course I do too, and I love to listen to other people talk about it as well. So thank you very much.
Thanks,
We
Greg.
really appreciate it.
All right. Good luck with everything.
Thank you.
Thank you.